March 23rd, 2006. I'm out here in Nenana, Alaska on the bank of the Nenana River, and we're working on a project to build erosion protection for this riverbank.
This photo of the same riverbank was taken in the summer. You can see how the soil is being undercut and washed away. To stop this erosion, we are installing 6 stream barbs. Stream barbs are submerged stone jetties that force the current offshore and dissipate the energy of the flowing water. As shown here in the construction plans, the process of building a stream barb starts with digging. For this project, a trench 5 feet deep and 20 feet wide was dug into the river bottom extending offshore. Some of the barbs are more than 100 feet long. Digging these underwater trenches would have been impractical in the summer because the river runs much higher and faster. The Nenana River pulses with power when the short summer season melts the ice and snow in the high mountains of the Alaska Range and the summer rains fall. Runoff from roughly 25,000 square miles of mountainous terrain drives this rushing giant river past the village of Nenana. Any hole excavated in the river bottom would be filled in almost immediately by silt when the river is flowing fast. We normally wouldn't try to control the Nenana River. It's notoriously unpredictable as it rips away its banks. In the summer, the river water races by violently, carrying tons of silt, rock, and mangled trees. The river shifts course constantly, destroying some areas and building up others. From the bank, it looks like a conveyor belt for silt and debris. Our project area is on the outside bank, downstream of a sharp river bend. In some parts of the project area, the river claims more than 10 feet of the bank every year. A road that once ran along the edge of the river here is now gone. Within 20 years, if we don't stop it, the river may undermine the main line of the Alaska Railroad. When the Alaskan winter approaches each year in October, the Nenana River subsides within its banks. The surface freezes and the dense silts settle out. Docile river conditions were critical in allowing for underwater trench excavation on our project, but an ice layer 40 inches thick created some problems. After outlining the barb area with chainsaws, a massive steel tube known as the torpedo was used to break up the ice. Pieces were then scooped up and the underwater trench was excavated. Immediately after completion of each trench, large boulders were dropped in along its length, followed by hundreds of cubic yards of rocks deposited with this dump box until each underwater jetty or stream barb was properly formed. You may ask why we used stream barbs rather than a continuous rock wall along the riverbank we protected. Our cost estimates indicated that a rock wall would cost roughly 3 times as much as the 6 stream barbs we installed. Additionally, rock walls on riverbanks tend to accelerate and focus the full energy of the flow downstream. This can cause unexpected negative consequences downstream of the project area. Stream barbs push the current offshore and dissipate energy as they control bank erosion. This is the first project to construct stream barbs on a large Alaskan river. We also believe this is the first time that stream barbs have been installed beneath thick river ice. The Nenana Native Council and the Bureau of Indian Affairs would like to commend our contractor, Fairbanks Excavation, for completing the project on time and within the budget in spite of extremely difficult weather conditions. The stream barb design was prepared by the U.S. Department of Agriculture, Natural Resource Conservation Service.